Yeah. Okay. So for binomial distribution, the experiment should have fixed number of trials. So for example, if we toss a coin 10 times, so that's mean there are 10 number of trials. So we'll consider each toss as a or each flip as a trial. So number two is each trial can result in only two outcomes. So we'll have only two outcomes in each trial. Okay, so I have already emailed you the YouTube link for the recorded lecture for the last class, and I'll also email you the YouTube link for today's class, maybe tomorrow or tonight. Okay. So each trial can result in only two outcomes. So that's mean in each trial we'll have only two possible outcomes. For example, if we toss a coin, then there are two outcomes only. We'll have either head or tail. So for binomial distribution, for each trial, it should have only two outcomes. And we'll label this trial as success and failure. So if we toss a coin, we'll have either head or tail. So if we consider head as success, if we are interested to get a head, then we'll consider head as success, then the tail will be failure. So each trial has the same probability of success, and each trial has same probability of success. So that's mean if you toss a coin 10 times, then each time you will have the same probability to obtain or to get a head, or you will have same probability in each toss to get a tail. So in number 4, each trial is independent from the other trials. So the trials are independent. So that's mean, for example, if you toss a coin 10 times, each time you can have any of the two outcomes, head or tail. So getting outcome in any trial, it doesn't depend on the outcomes in the prior trials or prior toss. So that's mean each trials are independent. But if the data is small compared to the population size, for example, if the data is 5% of the population size or less than 5% of the population size, then still, even though the trials are not independent, still the data might follow binomial distribution. Okay, so for binomial distribution, you need to remember the data should satisfy these 4 requirements. Okay, so now we'll go over an example. So if you flip a coin 3 times, so we flipped a coin 3 times, does this example follow a binomial distribution? So now you need to check whether this data satisfy all 4 requirements for binomial distribution. The first requirement is fixed number of trials. Since we are flipping the coin 3 times, that means the experiment has a fixed number of trials. That means 3 number of trials. So the first one is okay. However, the second one will have only 2 outcomes. So in each trial, we'll have only 2 outcomes. So if you toss a coin or if you flip a coin, then you will have either head or tail. So that's mean we have only 2 outcomes. So that is also correct. Third one is independent trials. So the trials are independent. Okay. So if you flip coin 3 times, each time you have chance to get any of the 2 outcomes. So that's mean getting ahead in second flip doesn't depend on the results or outcomes of the first flip, right? So that's mean the trials are independent. So this is also correct. And the last one is the probability of getting of success. That's here if we consider getting a tail as success, so we want to find the probability of getting a tail. So that's mean in this case, we'll consider the success is the getting a tail. So that's mean the probability of getting a tail is always 0.5 in this case. This is fixed. So each trial you have chance that you will get, you have 50% chance that you will get a tail. So that's mean the probability in each trials are same. So these data or this experiment satisfied all four requirements of the binomial distribution. So that's mean we can say that these data follow binomial distribution. Do you have any question? Okay, so now the question is, we know that the data follow binomial distribution. So how do we find the probability from a binomial distribution? So the binomial, you can use a specific formula or a specific function to find the probability from the binomial distribution. So this function is called binomial function. So this is denoted by B. B means binomial. X is the number of success we are looking for, and N is the number of trials. That means the total number of trials. And P is the probability of success in each trial. So X is the number of success, N is the number of trials, and P is the probability of success. So you need these three values to find the probability or to get the probability from binomial distribution. Okay, so now the question is, what are the possible values for X? X is the number of success. So here actually X should have maximum value N, because X cannot be more than N. So why? So for example, if you toss a coin 3 times, then the maximum number you can get a head or you can get a tail is 3, right? So if you consider getting a tail as success, then the total number, maximum number of success can be 3. It cannot be more than 3. So the possible values for X will be 0 to N. If N is the number, total number of trials, because in N trials, you can have 0 success, you can have 1 success, you can have 2 success, you can have maximum N success. So if you flip a coin N times, or for example, if you toss a coin 10 times, if you then you can have 0 head, 1 head, 2 head, 3 head, 4 head, up to 10 head. And similarly, if you flip a coin N times, then you can have 0 head, 1 head, 2 head, up to N head, right? So the maximum number, the number of possible number of successes are 0, 1, 2, up to N. Okay, so the formula for the binomial binomial probability is N CX. So that's mean N combination of N combination X, and P is the probability of success, P to the power X, 1 minus P to the power N minus X. So this is the function to find the probability from binomial distribution. So what does NCX represents? So this is actually the number of way you can get X number of success. So for example, if you consider, if we flip a coin twice, then that's at the outcomes. So if you consider 8 as success, so getting ahead as success, then, and X is the random variable, then the value of X will be, then we have 2 here, 2 head, we have 1 head here, we have 1 head here, we have 0 head. So the value of X will be 0, 1, 2. And in this case, if you want to, if we have, so for example, in this case, if you write B number, for example, you want to get X number of success, and N is the total number of trials. So how many times you flipped a coin? Twice. 2, and for example, probability of getting head is 0.5, then P will be 0.5. So then this formula will be N is 2, so 2C1. So then 0.5 to the power 1 times 1 minus 0.5, which is also 0.5 to the power N minus X. That's mean 2 minus 1. Okay. So we'll go over more examples, so don't worry about this one. So what does this 2C1 means? So how many ways we can get one head here? We can get one head in 2 ways. 2C1 means 2 times 1 divided by 1. That's just 2. Or you can use calculator to get this number. So that's mean this is saying that you can get one head in 2 ways. And this is the probability. This is the probability for each outcome of getting ahead. That's when this is the probability for this one, or this is the probability for also this one, and times how many ways you can get one head. So that's why we are multiplying with this number. Okay. So is it clear, or do you have any question? Okay, so in binomial distribution, N and P are called the parameters. That means they are related to the population, not sample. So N is the total number of trials, and P is the probability of success. And you already know that the population mean is generated by mu. Now, if you know the number of trials and the probability, then you can find the mean or the expected value of X for the binomial distribution, for the binomial random variable. So if X is binomial random variable with n number of trials and probability P, then the expected value of X, which is, you already know this is population mean, mu X, mu subscript X or mu X, which means the population mean for random variable X, and this is equal the number of trials time the probability. So this is the expected value. So if you know the number of trials, that's mean if you know N and if you know the probability P, then you can find the population mean for the binomial random variable, which is N times P. You can also find the variance and standard deviation. So what is the variance for binomial random variable? So variance of V of X means variance of, this is variance. This is variance of X, which is equal N times P times 1 minus P. The variance is N times P times 1 minus P. So the standard deviation is the square root of the variance. So if you take the square root of this number, you will get the standard deviation. So here standard deviation sigma X. So that means the standard deviation of X is equal a square root of N times P times 1 minus P. That means a square root of the variance. Okay, so now we'll go over some example. So here we have a particular telephone number is used to receive both voice calls and fax messages. Suppose that 25% of the incoming calls involve fax messages. Okay, so for binomial distribution, you know that there are only 2 possible outcomes, and either of the 2 outcomes you will consider as success. So here we have also 2 outcomes. One is voice calls, the other one is fax messages. So and we have considered a sample of 20 incoming calls. So sample of 20 incoming calls. So that's mean you are considering 20 number of calls. So that's mean 20 number of trials. So the number of trials is 20. So we have a fixed number of trials. So this is the first requirement of binomial distribution. And the second one is it has exactly two outcomes. Since in this case, we have only two outcomes, voice calls and fax messages. So the second requirement is also good. Okay, I didn't ask you yet to write present, so please do not do it yet. No. Okay. So independent trials. Now you have to check whether the trials are independent or not. Yes, the trials are independent. The type of one call doesn't depend on the type of the call just before that call, or doesn't depend on the previous type of call. So for example, if the first call is fax messages, then the second call will not depend on this outcome. Second call maybe involve fax messages or calls. Okay, or voice calls. So that's mean they are independent. So what is the probability of success? So which one will consider in this case as success? Fax messages or voice calls? Since we are given the probability of incoming calls, so that's mean here, or sometimes it's also depend on the question. So if in the question, if you see that we are interested about any specific outcomes, that outcome will be considered as success. Here we will find the probability for fax messages, right? So if you look at number part A, you see at most, find the probability at most 6 of the calls involve a fax messages. So that's mean we are interested about the probability of fax messages. So that's mean we'll consider fax messages as our success in this case. And the probability is given, which is 25%. That's mean 0.25. Since no one is here, I can take off the mask. Okay. So the probability of success is 25%, which is 0.25 here. So that's mean the probability of success, or you can say P is 0.25. So now we will find the probability since this is a binomial distribution. So we already determined that this is binomial distribution because the experiment satisfied all the 4 requirements of binomial distribution. So you can say that the data follow binomial distribution. So you can use binomial distribution in this case to find the probability. So here the number of trials n is 20 and the probability of success, probability of fax messages is 0.25. So this is the probability of success. So now you have to find the probability that at most 6 of the calls involve a fax message. So that's mean if X represents number of, okay, so number of fax messages. Okay, so this is our random variable. So now we have to find the probability that at most 6 of the calls involve a fax message. So that's mean we have to find the probability that X is at most 6. So the maximum number of success is 6. So that's mean we are looking for the probability X less than equal 6. We have to find this probability. So how can we find this probability? So what are the possible values for X here? The possible values are, can anyone tell me what are the possible values for X here? N is 20. So look at this number. So what are the possible values of X? Anyone? 0. Okay. Yes, 0, 1, 2, 3, 4, 5, 6. Yeah, in this case, the values of X from 0 to 6. But forget about this question, part A. What in general, what are the possible values of X in this case? N is 20. So the maximum N could be 20, right? So from 1 to 20. Yeah, up to 20. But we are here we have to find the probability when x is less than equal 6. So that's mean we have to find the probability when x is equal 0 plus when x is equal 1 plus when x is equal 2 plus x is equal 3 plus x equal 4 plus x equal 5 plus x equal 6. Okay. Now for each one, you have to use the binomial formula for the binomial distribution. So that's mean for each one, you have to use this formula. So you have to use this one for each to find its probability. So okay, let's see how can we find probability x is equal 0. So probability So how can I find probability x is equal 0? So probability x is equal 0 means n is 20. So C 0 and P is here 0.25. So that's mean 0.25 and power is x is 0. And then 1 minus 0.25, the power is 20 minus 0. Okay, so for each one, you have to write this formula. And then you have to use calculator to find the probability. But this is very time consuming. But you should know this. You should know this, the way of finding the probability. But you can also use calculator and you can also use Excel spreadsheet to find the probability. So if you have calculator, then you can use calculator, and you, this is for who is model of the calculator. Let me see. Okay, so if you have TI calculators, then you can use this command binomial PDF npx. N is the number of trials and P is the probability of success and X is the number of success. Or you can use binomial CDF. So what is the difference between these two command? Okay, I will show you what is the difference between these two. Okay. So if you have TI calculator, maybe any TI will be fine. I do not know who is a specific model will work in this case. I think any TI model is fine. Okay. So then you can use this command binomial PDF in PX, or you can use binomial CDF NPX. So now what is the difference between these two probability? So the difference is here, this means probability of X is equal to small x. That means exactly X is equal exactly that number. But in this case, CDF means this is cumulative probability. So that's mean this represents probability of X less than equal this number. So for example, if you consider binomial PDF, and suppose N is 20 and P is, for example, 0.25 and X is, for example, 5. This means probability X is equal exactly 5. But if you use this command binomial CDF 20, 0.25 and 5, This means you are looking for the probability that x less than equal 5. That's mean you are adding the probability x is equal 0, x is equal 1, up to x is equal 5. So that's mean you are finding the cumulative probability where x is from 0 to 5 if you use this command binomial CDF. So when you'll be using calculator, you have to be very careful which function you are using. Okay, so do you have any question? Okay, so since here we are looking for the probability x less than equal 6, so which function we should use here? We should use binomial CDF, right? Because we are finding the cumulative probability here. So you need to use binomial CDF. So binomial CDF 20, 0.25, 6, and the probability is 0.786. Okay, you can also use a spreadsheet to find this probability, and I will show you how to use the spreadsheet to find the probability. Okay, let me show it. Okay, so first you have to select equal, then binomial, BIN, binomial distribution, binomial distribution. Now you can see here binomial dot dist. So that's mean binomial distribution. So you will use binomial distribution function, not the binomial inverse or binomial distribution range. You will use binom by binom dot dist. That's mean binomial distribution function. Okay, now you can see here the first one is numbers s. So that's mean this is the number of success. Number s means number of success. So the first number is number of success. So our number of success was 6 because we wanted to find the probability x less than equal 6, right? And this is the number of trials. The second number is number of trials, which is 20, comma, probability of success, probability underscore s. So that's mean probability of success, which is 0.25, comma. Okay, so now you will determine whether you are finding the probability for a specific value of x or you are finding the cumulative probability. Since we are looking for the probability x less than equal 6, so that's mean we are finding the cumulative distribution function. We are using finding cumulative probability. So you will use cumulative distribution function. So you can use either true or false. If you use true, that's mean cumulative distribution function. So that's mean you are finding the cumulative probability. So since here we want to find the probability x less than equal 6, so that's mean this is cumulative probability. So you will consider true. And you will get the probability. This is 0.7857. Now you can check. Yeah, 0.786. So this is same. This probability we calculated using calculator, binomial CDF, and you can also find this probability using a spreadsheet. Do you have any question? Any question? Okay, part B is exactly 6 of the calls involve a fax message. So exactly 6. So that's mean we want to find the probability where x is equal 6. So we are looking for this probability. Exactly 6 calls. So you can use, in this case, if you use a spreadsheet, you have to use the option false because we are not finding the cumulative probability. Or you can also use the calculator, and in this case you have to use binomial PDF, not binomial CDF, because we want to find the probability for a specific value of x, not the cumulative probability. So you will use calculator to find this one, and the probability is binomial PDF 20 is the number of trials, and P is the probability of success, 0.25, and 6 is the value of X. So that's mean the number of success, which is 6, and the probability is 0.169. Any question? Okay, so here we want to find probability X is equal 6. Or you can also write the formula. This is 20, but you do not need to because you will be using calculator. So you do not need to write all of this. And the power of X is 6 times 1 minus 0.25. The power is 20 minus 6. Okay. The next one is, so we are finding the probability that at least 6 of the calls involve a fax message. So we want to find the probability that at least 6. So what does it mean by at least 6? So at least 6 means probability of X, the minimum number of X could be 6. So that's mean probability of X greater than equal 6. So now how can we find this probability using calculator? So if you use binomial CDF, since this is also cumulative, but if you use binomial CDF, it will always give you this type of probability, less than equal some number, not greater than equal some number. So here we have X greater than equal 6. But if you use calculator, it will always give you this one. So how can we calculate this probability? Anyone? How can we find the probability using calculator or a spreadsheet? Can anyone tell me? Yes. Yes, subtract 1 from probability 6. Yeah, subtract from 1. Yes. Yeah. Yeah, you have to subtract from 1. That's mean you have to take the complement. Yeah, thank you. But the thing is that you have to be very careful here. There is high chance that you might do mistake. So you have to be very careful. So we can write this one as 1 minus probability of, okay, can we write this? Is it the complement of this one? No. Yeah. This is not the complement of probability of X. Yeah, this is not the complement. The complement is, so the possible values of X are 0 to 20. And here X greater than equal 6. So that means 6 to 20. So the complement will be 0 to 5. So that's mean if you write this symbol X less than equal, then you have to write here 5, not 6. But if you use this symbol, if you use this one, this notation X less than, then you can use 6. Yeah, this is the complement of this one. But this is not the complement of this. So this is not correct. So either you will write probability of X less than 6, or you can write 1 minus probability of X less than equal 5. They are same. Because X less than 6, that means the numbers which are less than 6, so that means 0 to 5. And X less than equal 5, so that means the numbers from 0 to 5, they are same. Yes, you're right, X less than equal 5. Okay, so now if you use calculator, so since this part is X less than equal 5, so for this part you can use binomial CDF function. So if you use binomial CDF and 20 probability is 0.25 and the number of success is 5 here. So you will get 1 minus some number here, and that will be 0.383. So this is the probability. Any question? So in this case, probability of x less than equal 6. So that's mean 1 minus probability of x less than equal 5. So you can use this one to find the probability. Okay, so the next one is more than 6 of the calls. So you have to find more than 6 of the calls involve a fax message. So that's mean we are looking for the probability more than 6. So that's mean probability of x greater than 6. So the previous one was x greater than equal 6. So that's mean at least 6. So x greater than equal 6. Now we have more than 6. So x cannot be equal 6. X is more than 6. So that's mean x greater than 6. Or you can also write, if you want, you can also write this one as probability of x greater than equal 7. They are same. This means also 7 to 20, and x greater than 6 also. This means also 7 to 20. So they are same. So what is the complement of this one? So the complement of x greater than 6 is equal 1 minus probability of x less than equal 6. Yeah, this time it will be x less than equal 6, because if you take the complement of x greater than 6, it will be x less than equal 6. So the only difference is in the previous one, when you took the complement, it was 1 minus probability of x less than equal 5. Now it is 1 minus probability of x less than equal 6. Okay, so now you can find the probability using calculator, and the probability is this one. So x greater than 6. So that's mean 1 minus probability of x less than equal 6. So that's mean 1 minus binomial, since this is CDF cumulative. So 1 minus binomial CDF 20, and this is the probability 0.25, and 6 is the number of success, and the probability is 0.214. Okay, part E is determine the mean number of calls involving a fax message in 20 trials. So you have to find the mean. So mean for binomial distribution. So the mean is mu x, which is n times p. And number of trials is 20, and p is 0.25. So that's mean it will be then 5. So the mean is here 5. If you see here, yeah, the mean is number of trials. Here you can see the mean is 20 times 0.25. So that's mean the mean is 5. Okay, in part F, determine the standard deviation. If you are asked to find the sample variance, then it will be the sigma is equals to, sorry, variance is equal the variance of x is equal n times p times 1 minus p. So here you have to find the standard deviation. So you have to take the square root of this. So the square root of n times p times 1 minus p is 20 times 0.25 times 1 minus 0.25. So the standard deviation is 1.94. So this is the population standard deviation. Okay, so the next one is, do you have any question? Any question from this section? Okay, so if you do not have any question, then we'll move to the next section, section 3.6. So this is about Poisson distribution. The Poisson distribution is also a discrete probability distribution. and this is called Poisson distribution. And this is also kind of waiting time distribution. So what is the waiting time distribution? For example, if you are waiting at a traffic signal and you are counting the number of car passing the traffic signal in every hours or in every 2 hours, in a certain time, in a given time, you are counting the number of cars passing the traffic signal. So the expected number of cars passing the traffic signals during a specific time is the mean, is the expected value, is the mean for the Poisson distribution. So this type of distribution is called Poisson distribution. So for Poisson distribution, you need one parameter which is called mu, the mean, the expected number or expected value. Okay, so what is the x? So for example, I gave you example about the car passing the traffic signal at a given time. So the number of cars could be, for example, if you count the number of cars passing the traffic signal in every 5 minutes, maybe no car passed the traffic signals in first 5 minutes. So the number of cars could be 0, it could be 1, it could be 2, 3, 4, 5, and we do not know the fixed number, right? So here you do not need the fixed number. So the x could be 0 to any number. Okay, and mu is the expected number of cars you will observe, or you will say passing the traffic signal in every 5 minutes or in every 2 minutes. If the given time is 5 minutes, then in every 5 minutes. If the given time is 2 minutes, then in every 2 minutes. Okay, so that's why it is called waiting time distribution. This is also discrete distribution. And you can also consider, for example, at a certain hospital, how many patient visits the hospital in every 1 hour. If you wanted to know this, then the expected number of patients visits the hospital in every 2 hours will be mu, the expected value. And the possible values of x will be the number of patients. So it could be any number, it could be 0, but it should be it should be integer, right? Because the number of patients cannot be any fraction, right? So that's why this is also discrete distribution. And this type of distribution is called Poisson distribution. So for Poisson distribution, you need one parameter which is called mu, and mu is always positive because this is average number of, for example, if you consider the car example, then average number of cars. If you consider the patients example, then average number of patients. So it's always positive. So mu is always positive here. And x is from 0 to any number, 0, 1, 2, 3, 4, 5, 6, any number. Okay, so x is the random variable for Poisson distribution. Then the distribution function, in case of binomial, it was denoted by b n p x. But in case of Poisson distribution, it is denoted by p for Poisson. So p of x mu. So here the value of x is from 0, 1, 2. So x is the value of x, and mu is the parameter. Mu is the expected value of x, or mu is the mean, population mean for the Poisson random variable. Okay. So in this case, you can have also some other parameter. Instead of mu, you can have parameter lambda. Okay, so in different books use different notation. Some book use lambda as a parameter, and some book use mu as a parameter. So, but they are the expected value of x. Okay, so for Poisson distribution, the variance and the mean are same. The expected value of x and the variance of x are same. So the population mean and the population variance are same, which is just mu. And the standard deviation is the square root of the variance. So that's mean square root of mu. So the Poisson process expected number of events during a given time interval. So mu is the expected number of events during a given time intervals. And sometimes mu will not be directly given. Sometimes you will be given another number, another value, and we denote it with alpha. And alpha is the expected number of events during a unit interval. For example, maybe if you consider the car example, so if the given time is 2 hours, maybe you will be given the expected number of cars passing the traffic signal in 1 hour. But we are interested about 2 hours period. But the expected number was given for 1 hour per hour. So in that case, you have to calculate the mu. The mu will be the expected number during a unit interval times the number of hours or number of units given. So that's been times t. So mu will be alpha times t. So sometimes the mu will be directly given, and sometimes you have to calculate the mu. Okay, the first example is, suppose the number x of tornadoes observed in a particular region during a 1 year period. So we are given in 1 year period has a Poisson distribution with mean mu is equals to 8. So we are given x is random variable, and the random variable follows Poisson distribution, and the mu is also given, which is 8. Now we have to find the probability that the observed number of tornadoes is at most 5. So that's mean the maximum number of tornado is 5. We have to find the probability. So that's mean we have to find the probability x less than equal 5. And where x is the number of tornadoes during 1 year period. Okay, so how can we calculate this probability? You can use the calculator, since this is also CDF, this is also cumulative probability, because we are finding the probability x less than equal 5, not for a specific number, a specific value of x. So that's mean this is cumulative. So you have to use Poisson CDF if you use the calculator. But if you use the spreadsheet, then I can show you how to find this probability. Here 8 is mu is 8 here. This is the parameter, so we need to remember this number. So now I'll show you how to find this probability using a spreadsheet. Okay, so for binomial we used the comment binomial distribution. Now in this case we'll use Poisson, P-O-I-S-S-O-N, Poisson.dist. That's when Poisson distribution. So you have to use this comment. So the first one is x. So that's mean this is the value of x. So what was the value of x in our case? It was, I think, 5, right? In our case. Yeah, it was 5, because we were looking for the probability x less than equal 5. Comma, the second number is mean. So the mean was, mu was 8. And the third one is, we have two options here, true or false. So if you consider true, so that's mean you are calculating the cumulative probability. And if you consider false, so that's mean you are finding the probability only for a specific value of x. Since here we are finding the probability x less than equal 5, so that's mean this is cumulative probability, so you have to consider true. So this probability is 0.191236. Now let's check the results. 0.191236. Yes, this probability is 0.191. So you can either use calculator or you can use a spreadsheet. The second one is probability that the observed number of tornadoes between 6 to 9 inclusive. Okay, so for binomial distribution, we didn't see any example like this. We didn't find any probability between any two number. I will discuss this one also for binomial distribution. Okay. So we have to find the probability where x is between 6 and 9 inclusively. So what does it mean by inclusively? Inclusive means the x is greater than 6 and also equal 6. So x is between 6 and 9, and x is also equal 6, and x is also equal 9. So if you do not have this word, if you have just between 6 and 9, so that's mean if you do not have this, that's mean probability 6 less than x less than 9. So that's mean you will find the probability only when the x is between these two numbers. X is not equal to 6 or x is not equal to 9. But if you have inclusively, so that's mean x is also equal 6 and x is also equal 9. So now you have to find this probability. Okay, so how can you find this probability? If you use calculator, so if you use this command, it will give you the probability x less than equal 9. But we want to find the probability where x is between 6 to 9 and inclusively. So if you use this one, that will give you probability for x equals to 0, 1 up to 9 if you use this command. But here x is 6 to 9. So now we have to subtract some probability. So that's mean we have to, here we need actually 6 to 9, but we calculated the probability from 0 to 9. So we have to subtract the probability from 0 to 8. So how can you find the probability from 0 to 8? So that's mean you have to use Poisson CDF 8, 5. Oh, sorry, we have to subtract 0 to 5 because here we have 6 to 9, but here we have 0 to 9. So to get this number 6 to 9, we have to subtract 0 to 5. So that's why we subtracted Poisson CDF 8, 5, not 8, 6. You have to be very careful. Okay, so so for this one, I'll discuss some more example. Let's see. Okay. Okay, so if you use calculator, so if you want to find the probability, for example, 2, for example, 7. So you want to find the probability from Poisson distribution where mu is 8, and you want to find the probability where x is from 2 to 7 inclusively. So in this case, you have to use Poisson POI. Sorry, you have to use POISSON CDF. 8 is the mean, and this is 7. Minus, so if you use this function, that's mean you are finding probability from 0 to 7, but we need from 2 to 7, not 0 to 7. So you have to subtract 0 and 1. So how can we subtract 0 and 1? So this is also Poisson CDF 8, 1. So similarly, if you have, for example, 2x less than 7. So how can I find this probability? POISSON CDF 8. Should we write 7 or 6 in this case? Which number we should use in this case? 7 or 6? Anyone? Yes, 6. We should use 6 because here x is from 2 to 6, not 2 to 7. X is between 2 to 7 and 2 is inclusive. 7 is not inclusive. So that's mean we have x is from 2 to 6. So that's mean you will use Poisson CDF 8, 6 minus Poisson CDF 8, and you have to subtract 0 and 1. So that's mean 8, 1. Do you have any question? Okay, so now if we want to find probability of x equal 1, in this case, you are not going to use Poisson CDF, you will use just Poisson PDF. And mu is 8, and we have just 1. So you have to just use this one. And if you consider one more example here, for example, if you want to find 3x less than 8. X is between 3 and 8, not inclusive. So in this case, you have to just write Poisson CDF 8, and in this case, it will be 7 because 8 is not inclusive, minus Poisson CDF 8, comma. So X is from greater than 3, but not from 3. So that's mean you have to subtract 0 to 3. So that's mean this number will be 3. So when you will be calculating the probability using calculator or using a spreadsheet, you have to be very careful because there is a chance that you might do mistake. Okay, so the next one is probability that the observed number of tornadoes is at least 10. So that's mean the minimum number of tornadoes is 10. So that's mean X is greater than equal 10. So since this is greater than equal, you cannot directly use the calculator or a spreadsheet. First you have to take the complement. You have to make it less than equal. So the complement is less than 10, or you can also write 1 minus probability X less than equal 9. So you have to just take the complement. Okay, similarly for part D, probability that the observed number of tornadoes exceeds the expected number by more than 1 standard deviation. So what does it mean? The probability that the observed number of tornadoes exceeds the expected number, so that's mean X is greater than the expected number. So expected number means mu plus by more than 1 standard deviation. More than one standard deviation means 1 times the standard deviation sigma. So that's mean we are looking for this probability. Is it clear, or do you have any question? Actually, for this part, understanding the question is little tricky. If you understand the question, then you can easily find the probability. But if you do not understand the question, then you will get incorrect number. Is it clear what we are looking for here? We are looking for the probability of X where X is greater than 1 standard deviation from the mean. So that's mean mu plus 1 times the standard deviation. So 1 standard deviation away from the mean. So if so if our mu is here, 1 standard deviation greater than means mu plus sigma. So that's mean we are looking for the probability for this part. If you are asked 1 standard deviation below from the mean, so 1 standard deviation below means mu minus sigma. If you are said that 2 standard deviation below from the mean, that's mean mu minus 2 sigma. If you are say 2 standard deviation above, means mu plus 2 sigma. 3 standard deviation above means mu plus 3 times standard deviation, 3 times sigma. So here we have 1 standard deviation more than the mean. So that's mean X greater than mu plus 1 times the standard deviation. Is it clear? Okay, so now we know the number, we know mu, we know sigma. So for Poisson distribution, mu and The variance are same. That means the mean and variance are same. So it will be 8 plus 1 times sigma, and sigma is square root of 8. And this is equal probability of x greater than 10.8. So x greater than 10.8. We know that x is always integer number. X could be positive integer or 0. So x could be 0, 1, 2, 3, 4, 5, 6. So 10.8 greater than 10.8 means x greater than equal 11. Or you can also write x greater than 10. Yeah, whatever it is. So now to find this probability, you cannot directly use the calculator. So what you can do, you need to take the complement of this one. The complement of this one is 1 minus probability of x less than equal 10. And then you can, for this part, you can use this CDF function, Poisson CDF A10. Any question? Do you have any question? Okay, part E is probability at most 14 tornadoes in 2 years. Okay, this is different from the previous questions. So probability at most 14 tornadoes in 2 years. The expected value which was given, it was for 1 year, the number of tornadoes for 1 years. But the given periods is now 2 years, right? So that means we have to find the expected value for 2 years, but we have the expected value for 1 years. So in the previous case, the mu was 8, but in this case, the mu is different because this mu was for 1 year. Because for the previous examples, we have calculated the probability for each year period. But now the given interval or given time period is 2 years. So you have to find the expected value for 2 years. So what is the expected value for 2 years? The mu will be the expected value for 2 years. For each year, or for 1 year, it is 8. So for 2 years, it will be 8 times 2. So that means the expected value is 16. So in this case, mu is 16. Okay, so if we are said that the number of tornado is, so if the given period is 3, then what should be the mu? If we want to find the probability for 3 years period, then what will be the value of mu? Yes, mu will be 24 because it is 8 times 3. If we are given, if we are looking for the probability for is 6 months period, then what will be the mu for is 6 month? 4, yes. If we want to find the probability for is 3 months, then you have to calculate the mu for is 3 months, right? Yeah, so when you will be finding the probability from Poisson distribution, you have to be very careful when you will be calculating the value of mu. Okay, so here the mu is 16, and we want to find the probability that x is at most 14. So that means x less than equal 14. So you have to use Poisson CDF. Mu is 16 and x is 14. You can use either calculator, or if you want to use a spreadsheet, then you can go here. Use the spreadsheet. Okay, so we are using Poisson, POI, the Poisson distribution, and first number is 16, comma, we are looking for the probability x less than equal 14, and this is cumulative, so we are using true. So this probability is 0.755918, and let's check the result. 0. Yeah, 0.16 and 14 from the Poisson. Oh, let me check again. The Poisson is 16, comma 14, true. Oh, I did mistake, I think. Oh, first number is x. First one is not the mean. So the first number will be x. So that's mean 14, 14, comma, yeah, be careful when you will be calculating this. Yeah, then 14, comma 16. Yeah, the middle number is the mean. Now we have 0.367. Yeah, this is correct now. 0.367. Okay, so probability at least 45 tornadoes in 5 years. So now the um, time period is 5 years. So the mu will be 8 times. 8 is for number of tornadoes in 1 years. So in 5 years, it will be 8 times 5. So it will be 40. So mu is 40. So now we have to find the probability where x is at least 45. So that's mean we have to find probability x greater than equal 45. And this is the complement of probability x less than equal 44. So now you can use this number to find the probability Poisson CDF 40, 44. And probability between 20 to 25 inclusive and in 3 years. So here the time period is 3 years. So that's mean the mu is 8 times 3. Mu is 24. And we are looking for the probability 20 to 25 and inclusively. So that's mean they are inclusive. They are also equal. So that's mean x greater than equal 20 and less than equal 25. So this means the Poisson CDF 24, 25. So that's mean this one minus the Poisson CDF 24 and comma x will be 19 because we want numbers from 20, sorry, from 24, sorry, 20 to 25. But if you use this number here, it will give you the probability from 0 to 25. But we need 20 from 20 to 25. So you have to subtract from 0 to 19. So that's why we used Poisson CDF 24, 19. And this probability is 0.452. Okay, the next one is, okay, we have one more example. So now I'll give you 5 minutes or 3 minutes for attendance. So you have to type present. And after that, we'll go over this example. I think everyone is done with the attendance. So let's go over the next example. Okay, the next one is consider writing onto a computer disk and then sending it through a certifier that counts the number of missing pulses. Suppose this number x has a Poisson distribution with parameter mu, and mu is 0.2. What is the probability that a disk has exactly one missing pulse? So here we have mu is 0.2. We have to find the probability x is exactly equal 1. So you have to find this probability. So in this case, you have to use Poisson PDF, not CDF. And the probability is, so the mu is 0.2. So if you use the calculator, then it will be 0.2 and exactly 1. So that means just 1. Poisson PDF. Do not use CDF in this case because we are finding the probability x is equal exactly 1. So this is 0.164. What is the probability that a disk has at least 2 missing pulses? At least 2 missing pulses. So that's mean probability of x is greater than equal to. So at least 2 missing pulses. So this is the complement of 1 minus probability of x less than equal to 1. So since this is x less than equal to 1, so this is cumulative probability. So you will be writing Poisson CDF. So this is the CDF function. And part C is if two disks are independently selected, what is the probability that neither contains a missing pulse? So this question is a little different from the other questions. So we are finding the probability that two selected, independently selected disk neither contains a missing pulse. So doesn't contain a missing pulse means the value of x is 0. So we have two independent event. So that's mean the first has none, so no missing pulses, and the second one also has no missing pulses. And the random variable x is for its disk. So here they are, since they are independent, so you have to look at this word independently selected. So when they are independent, we know that the probability of the intersection of two independent event is equal the probability of the product of the probability of each event. So that's mean the probability that the first has none and the second one has none. Okay. So the first disk has no missing pulse. So that's mean the value of x is exactly equal 0 times the second one has no missing pulses. That's mean the value of x is exactly equal 0. So that's when we are finding the probability of x is equal 0 times probability of x is equal 0. And now for this one, since this is exactly equal to 0, so you should use Poisson PDF. So Poisson PDF 0.2 comma 0, which is this one. So the probability will be this one times this one. And the probability is 0.670. Do you have any question? You might have asked this question in different way. So if you are asked this question that two disks are independently selected, and what is the probability that one has no missing pulses and the other one has two missing pulses? So for example, if you are asked to find the probability that so for example, two disks DI are randomly selected, independently selected, independently selected, And the first one has no missing pulses, and second one has two missing pulses. So that's mean we are looking for the probability that first one has none, intersection second one has two, right? And since they are independent, so that's mean the first one has none times second one has two, and this will be probability of none means 0 times probability of x is equal to. Okay, so now you can use the Poisson PDF function to find the probability, and you will multiply this to probability to get the result. So I'll stop here today.